Okay, so for this last example, we're going to write another algorithm that uses a depth-first traversal. And this is a really useful function. It retrieves all the elements that have an attribute that match a given attribute value. And it's called, oddly enough, getElementsByAttrVal. It works by taking three arguments. There's the node that we're interested in. That's the starting point. And we're going to look for elements inside O node here that have an attribute the same as s@name and a value that's equal to s@val right here. The way it works is we have an internal array here named a_nodes, and we also have a locally defined function inside our outer function here. The locally defined function is called processNodes. This is our depth-first traversal algorithm that's going to look through all of the nodes and check to see if they in fact have an attribute that matches the value we're looking for. Each time we find a match, we're going to add that node to this internal array right here. And when we're all done, we're going to return that array back to the caller. This is a really powerful function. You can use it to quickly build up lists of nodes that have attributes that have a given value. And it also illustrates the concept of having a nested function inside of another function. Let's have a look at the code in action. Okay, so here we are in the sample code. This is pretty much the same sample code that I've been using up until now with a major difference. You can see I've gone up to the test XML data here, and I've added some attributes to some of the elements. So I've added attribute type equals test to the B, the G, the I elements, and on the J element, I've added type equals blah. So for testing, we're going to be looking for all the elements that have type equals test. So down here in the testing area, you can see that what I'm doing is I'm getting a reference to the top level A tag. That's the root of the document. And I'm calling getElementsByAttrVal on the top level tag. And I'm looking for elements that have a type attribute equal to the string test. And I have a string variable down here. It says nodes with attribute test. And I have a loop that's going to build up a list of nodes that match the result. So this result right here that's returned by getElementsByAttrVal, this is going to be an array of all the elements that match this criteria right here. Let's go ahead and write the code. So I'm going to declare my local array and initialize it to being empty. And then I'm going to write my internal function. And this is my internal processNodes function. I'm going to call this from within my getElementsByAttrVal function. So I need to call processNodes, and this is what kicks off the process here. And at the end of the day, we're going to return the nodes array. And for processNodes, we're going to pass in onode, and we're going to pass in the nodes array, because that's going to be modified. And then we're going to pass in the name and attribute values that we're looking for. So the processNodes function, that's going to take these arguments right here. So let me go and copy those guys onto this function right here. And I'm going to change the names slightly just to avoid confusion while we're reading the code. So we're going to call this a node list, and that should be good enough. So inside processNodes, we're going to check to see if oNodes.nodeType, and this is something that all nodes have. They all have a node type. We're going to compare that against the constant value on the node class to be an element node. And the reason we're going to do that is because only element nodes can have attributes. So there's really no point in comparing other kinds of nodes, like text nodes or comments or C data sections. All of these are XML data types, but they can't have attributes, so we might as well exclude them. Okay, then we're going to have a local variable called sattr, and we're going to get the attribute that we're looking for from the node. And we do that by calling the getAttributeDom function with the s@name. If this is not equal to null, then we need to check to see if it's equal to the value that we're looking for. And we do that by saying if s_attr equals s_attval. And if they match, then we say a node list dot push, and we're going to push the node onto the array list. Now that we've done that, we have to recursively call the function to do our depth first traversal. So we're going to say for var n equals onode.firstChild, n is not null, and n equals n dot next sibling. And inside this for loop, we're going to call process nodes again. And process nodes, we will give the n argument, because that's the child node that we're going to process. We have to pass in the node list so that we can keep on adding results. And we have to pass in the attribute we're looking for and the value that we're looking for. At this point, we should be in a place where we can test this out. Let's look down here. So remember, starting at the A tag, we're looking to build a list of all the elements that have the type attribute set to test. So if we look back up in the sample XML, that should be the B tag, the G tag, the I tag, and it should exclude the J because it has a type attribute, but it's not equal to test. It's equal to blah. Let's go ahead and run this in the browser and see what happens. So you can see nodes with attribute test, B, G, and I were all found, and J was excluded like it should have been. So let's try it in Firefox. Okay, same result. You can see nodes with attribute test, B, G, and I, and J was excluded the way it should be. Okay, once again, we've built a real-world DOM function that you can use in your real-world work. So please feel free to go ahead and use that code in your projects. And that concludes this chapter.